In this video, I'd like to talk about the math question of the day for Saturday, April 15th, 2023. And with this problem, we need to find the derivative of this function f of x. And to solve a problem like this, you will need to understand basic calculus since we are dealing with differentiation or derivatives. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. We're finding the derivative of this function, the first derivative, and we're taking that derivative with respect to x since that is our independent variable. And our first step is to rewrite all of these terms involving x with fractional exponents. So remember that assuming x is a positive number, we can rewrite an expression where we have, let's say, the nth root of x to the m as x to the m over n, where the power we raise x to, that is the numerator of our fractional exponent, and the root we take, that is the denominator of this fractional exponent. So let's start by rewriting our function. We have that f of x is 10 multiplied by x to the 3 over 5 power, since we're raising it to the third power and we're taking a fifth root. This is a square root, so we have x to the 7 over 2 power. And here we have 6 multiplied by x to the 8th over 3, so the 8/3 power, and we're subtracting 3 from that. Now, once we write it like this, we can just use the power rule for derivatives. And in general, let's say we have g of x is some constant a multiplied by x to the b power. When we take the derivative, we find the rate of change of this function. We can bring the exponent down, and we multiply it by whatever this coefficient is, and then we subtract that exponent by 1. And this works for fractions as well. So let's apply that principle. We're looking at the derivative of our function f with respect to x, which we can write it as f prime of x, or we can write df over dx if we want to be explicit about our independent variable there. And we will bring down the exponent so that we're multiplying, but we will have to subtract 1 from our exponent. And we're subtracting 1, so in other words, we're subtracting 5/5, so we will end up with minus 2/5 there. We bring down the 7/2 here. We have x to the 7/2 minus 1, or minus 2/2, so that brings it to 5/2. Then we repeat the process here. This is getting a bit messy, so let me do it down here. We bring the 8/3 down, so 6 multiplied by 8/3, multiplied by x raised to the 8/3 minus 1, or minus 3/3, so that would be 5/3. And the derivative of a constant is 0. Since the rate of change of a constant is 0, constants do not change. And at this point, we can simplify everything. We'll just write f prime of x, and 10 divided by 5, that's 2, so we get 2 times 3, which is 6. So 6x to the minus 2/5. Then we have minus 7/2 x to the 5/2. And 6 divided by 3, that's 2. 2 times 8 is 16. So plus 16 multiplied by x to the 5/3 power. And this right here will be the derivative of our function f with respect to x. It is the rate of change of our function. And if you do want to check your work with this, there are plenty of good online programs that you can use, where if you plug in a function, you can ask that software to calculate the derivative of the function. So when you're first learning these, I encourage you to use software like that, not to do your work for you, but to show that your work is actually correct.